wonder what a flying car looks like and how it works? Or are you interested in pursuing a career in STEM but just don't know where to start? Or are you just looking for a meaningful way to spend your dream holiday? Learn from some of the best in the aviation industry as they share their amazing career and the exciting experiences that they have. Explore with innovators and entrepreneurs as they come up with exciting technologies to revolutionize the field. And hear from educators who bring science to life through experiential learning. Aspire Week is here to inspire you. Join us online from 14th to 20th June. See you soon.
Hello, and welcome to Aspire Week, where we explore flying cars, innovation and technology, and careers within the aerospace industry. In this session, we have Mr. Rajarshi Maiti, Materials Capability Acquisition Engineer at Rolls-Royce. Raj, welcome to the show.
Thank you very much. Very happy to be here.
This will be your 6th year at Rolls-Royce, right?
That's right. 6th year.
Can you tell us a little bit about your role and how it has evolved in the years?
Definitely. I think this is my first job. So obviously, when I first joined as a green-eyed, excited, enthusiastic engineer, I joined in the team doing R&D. So I was looking at R&D of new products. And then over time, I moved on to repair, which is looking at R&D still, but looking at for products that are already in service with our customers. And now I am looking after a program where we develop new technologies and in partnership with our local universities and research centers.
Okay, so it's a very innovative, it's a job that requires a lot of innovation.
Yes, definitely.
Interesting. I'm sure our audience is looking forward to hear some of these technologies that you are working with. I will now leave you to share more, and we'll be back with you after your presentation.
All right. Thank you so much, Johnson. Hi, afternoon, everyone. It's really great to be here, and I am genuinely excited to share about Rolls-Royce and, more importantly, about the future of flying, because I think that is something that is quite exciting that's going on. First and foremost, I would like to thank Aspire to giving me the opportunity to be here. And, it's quite encouraging to see so many people excited in STEM. And I hope today I can, well, not aspire, but inspire you guys to push forward for a career here. And I will be very happy to take any questions. So let me just give you a bit more about myself. So as you guys just heard with my conversation with Johnson, I joined Rolls-Royce 6 years ago. So I have been working here, and there has been a lot of changes in things we do. We have moved across technology. So like we talked about, there is a lot of innovation. But in terms of innovation itself, I think the things that we look at do change because that's what the need of the hour is. I joined Rolls-Royce from fresh graduate from NTU Aerospace Engineering. And before that, I was in Singapore for about 15 years. Okay, so let's get started. So before I move on to technologies, can I just check? Actually, maybe it's a bit more difficult because, and that's one of the things I really miss about this new times, that I would have been in person together with all of you, and I can ask you all to raise hands. So I'll skip that bit. But Rolls-Royce, when you hear the name, a lot of you might associate us with cars, the really fancy cars. But the thing is, that business separated in 1973, and we as Rolls-Royce PLC don't do cars anymore. What we do is we are the world-leading industrial technology company. So we are effectively a technology company. And what our mission is better power for a changing world. Keep that at the back of your mind, because I will walk you through the presentation and we'll see how this better power for the changing world is embedded at the core of our innovation. So a bit more about Rolls-Royce. What do we have? We have three key businesses. We have the civil aerospace, which encapsulates all the commercial and the business jets. So any planes that you have taken off, if it's a Rolls-Royce engine, that forms part of our civil aerospace business, which is a big chunk of our business. So we have, like it's here, 35 different types of aircrafts and close to 12,000 engines in service. On the second one, we have Rolls-Royce Power Systems. Rolls-Royce Power Systems are basically, we provide engines for industrial usage, which means these can be on marine businesses or can be even industrial gas turbines. So at the core of the technology, it is still generating power, just that that power is not utilized for flying aircrafts, but for other purposes. And finally, we have our defense business, where we engage with the military to provide propulsion for their aircrafts. So that is also one of the other big parts of our business. So that's where we are as Rolls-Royce. But when we say better power for a changing world, what do you mean by that? The challenge in this changing world is that the activities today are extremely focused on sustainability, on green power, and basically environmentally friendly solutions. And that is a big challenge. If you know, recently there was the G7 summit, and environmental and sustainability was also a part of the conversation. So for Rolls-Royce, it's always been about making sure we have long-term strategy to move towards a sustainable aviation future. And that's what we are here to talk about today. Now, this pandemic has caused us a bit of a setback, as you all already know, but that doesn't mean we change what we want to do. Yes, right now it's about making sure we survive this pandemic, but we also need to have one eye in the future to make sure that our goal on sustainability always remains. And for this, we need to be enabled in an environment where by 2050, we are net zero emission. And that is a big challenge because we are very, very far from that. So what can innovation do? Answer is a lot. So before I go into that, let me just give you an overview of how our jet engines work. And then I will kind of bring in how innovation is going into this jet engine to make it more sustainable. Okay, so let's take a quick look.
Rolls-Royce is one of the world's leading engineering companies, designing and developing high-technology power solutions based on very efficient engines. These are used for applications on land, at sea, and in the air. Our engineering strength is built on two key technology platforms, the gas turbine and the piston engine. So how do they work? In the case of the gas turbine on an airliner, air is sucked in via the large front fan. The majority of the air is directed around the engine as pure thrust. The rest enters the engine and is squeezed through compressors consisting of a series of blades. Pressure increases at each stage as the air is squeezed. In the combustion chamber, the air is mixed with fuel and ignited. The hot air explosion is directed towards the back of the engine, generating more thrust and rotating the turbines, which in turn are linked to the front fan and compressors. A piston engine also operates by air being compressed and mixed with fuel. Air is drawn inside a cylinder, then compressed by a piston and mixed with either diesel or liquefied gas. As the mixture ignites, the energy created pushes the piston to the bottom of the cylinder. The piston then returns to the top in a continuous process. Rods connected to a crankshaft convert the vertical movement of the pistons into a rotating motion. As a result, the piston engine can power a wide range of applications: electrical generators, ships, vehicles, and railway locomotives. Efficient power on land, at sea, and in the air. Rolls-Royce, creating better power for a changing world.
So that was an overview of what Rolls-Royce does, how our engine operates, and this is at the core of what we do. In order for us to deliver these engines, which we have earned as of today about 100 million flying hours, it is important for us to keep at the cutting edge of innovation, because not only we are going to fall behind our competitors, but we are going to fall behind world's industry standards of how a business should operate in terms of sustainability. So let's dig into a bit more on the sustainability. Now, Rolls-Royce has had many different engines, and most of our engines, they are called Trent engines. Interestingly, this name Trent is based after a river in Derby, UK, where is our headquarters. At every subsequent Trent engines, we have provided 10 to 15% improvement in our fuel efficiency. And that has been very, very important for us to deliver that goal of net zero carbon emissions. And as of today, the Trent XWB is one of our most efficient engines that has cut down fuel emissions by close to 15%. And not only that, we are now further innovating to look at how even at this 15% reduction, we can go even further. Now, something to take note relating back to the video, you saw the large fans that you see in front of it. These fans are one of the big drivers of the efficiency of how efficiently a fuel burns. So what we have done is we have innovated into a composite fan blade. So the difference between this and the previous one is you will see that this fan blade is blue in color with a very thin silver lining in front. This fan blade is made purely out of composites everywhere that is blue in color. That makes the engines a lot lighter, and spinning these fans become much easier. That allows us to get a lot more improvement in our fuel efficiencies. Now, on top of that, we have also started looking into our next generation of fans, which is the UltraFan, that is approximated going into service in 2030, which will give even another 25% reduction in our carbon footprint. So as you can see, development of these engines, we have slowly started to move towards that goal of having a sustainable engine and reducing our carbon footprint. But there is always this saying that you can only do small incremental improvements, but unless you make a very significant change in the way you do things, it's very hard to make a step jump. And it is the step jump where we are focusing on for the next few years. And in order for us to deliver that step jump, we actually call it almost the fourth industrial revolution in the industry, where it is looking at three main things. Electrification, so moving away from this gas turbine engine, the engine that burns the fuel and rotates the parts. Aviation fuel, sustainable aviation fuel, or SAF, which means the fuel that we use for these jet engines, can we move away from using all our petroleum-based fuels into something that's more sustainable, something that can be regenerated. And finally, digitization. Digitization is important because it allows us to prevent incidents from happening that can also lead an impact into the sustainability. So these are the three main things I will cover today to give you a flavor of how Rolls-Royce is moving towards the flying of the future. So, sustainable aviation fuels, or SAF. Sustainable aviation fuels are very, very different from our traditional jet fuels. And just to give you an idea, today, we are 100% jet fuel utilization. Now, jet fuel is made from the standard, our petroleum. It is processed and then gotten to the grade that is required for being jet fuel. But that means we are utilizing non-renewable resources. And that is something we want to move away from. That's why we are moving to SAF that is made from renewable resources, things like cooking oil and bio waste, that allows us to get to that level of sustainability. SAF is not completely new. It has been used in other industries, smaller scale power generation, for about 10 years. And even for smaller flights, SAF has been used, but we have never used it at a commercial level. And that's where we want to move into. So Rolls-Royce has committed to delivering SAF. And as of February of this year, we conducted 100% SAF-powered flight to unlock the future potential of SAF. And we have done this in our business jets because those are smaller jets. And now the plan is we want to make this into our larger commercial jets that will allow us to get to our goal of 2050 net zero emission. If you might be wondering what is some of the challenges of SAF, first and foremost is obviously production. We simply do not have a supply chain for getting SAF to the levels that we need, because in the next few years, we will need up to 400 to 500 million tons of SAF if we want to move completely towards replacing our jet fuels. So we are working hand in hand with other partners like BP to ramp up the production while we are working with the R&D side to figure out how we can use SAF as part of our flight. So that is SAF. Now this, bear in mind, it's still a traditional jet engine, but instead of powering it with jet fuel, we are using SAF. But the other bit, which is, can we move completely away from using any form of fuels? And that is where electrification comes in. Now, I'm very sure all of you have heard of all the fantastic things that Tesla has been doing. And a lot of car companies are now moving towards hybrid cars like Prius, or even fully electric cars like Tesla. And the reason for that is that carbon footprint, because your electric cars have extremely little to no emissions. But as you know, with electric cars, the challenge is, you might be wondering, just take a look at Singapore. EDB plans to get electric vehicles onto the roads. But right now, almost if you go to your Google Maps just within where you are and you click petrol pump, you will definitely find 5 to 6 petrol pumps within a couple of kilometers of radius. But we just simply don't have that infrastructure for electric cars. So charging of cars, the infrastructure is not there. Now imagine that and scale it up to the level of electric aircrafts. So there is a lot of infrastructure work that needs to go on. But on top of that, we need to figure out how to generate enough power that a jet engine generates from an electric engine. And currently, the challenge is battery size. So Rolls-Royce has been working extensively with a lot of partners to look at how can we tackle this problem and get to a power density that is able to do propulsion on a fully massive commercial aircraft. We are 10, 20 years away from that, but we have made a good start, and we have started having small test flights. And just last year, Rolls-Royce completed its first test flight to look at electric aircrafts. So let me just show you a couple of videos about it, and then I will let you know a bit more about our journey to electrification. Sorry, that was my bad. That was the end of the video. There you go. So basically what you just saw was an air taxi. It's almost like an Uber, but for aircrafts. And that is one of the first goals we have, to have these small air transportation. But just from the video, you could see the complexity that you actually need to have engines that are able to rotate to allow us to take off, fly, and then land. So this generates a lot of complexity in terms of engine design itself. But on top of that, all of this has to be done through electric power, which right now, the size of the battery to deliver this kind of power, it needs to be shrunk close to by 10, a factor of 10, in order for us to make it feasible that we can mount that battery on an aircraft and the aircraft can take off. So that is one of our biggest challenges. Next, what I would like to share is actually a sneak peek into a project called Excel. It is our single-seater demonstration for electric vehicles.
This is a key moment in electric aviation where we've produced the aircraft that's going to go break the record. So the current airspeed record is 210 miles an hour. We intend with our aircraft to go 300 plus miles an hour.
If we can break the world record, electric aviation is here to stay.
I mean, this is history in the making. High-powered electric propulsion is going to bring such a lot to aerospace.
This is about how do we start to champion electrification in aerospace? So how do we be able to show people what is possible? When we go to undertake the speed record, there are some rules that are set about.
Sorry, I wasn't sure.
This is a key moment. The current airspeed record is 210 miles an hour.
High-powered electric propulsion is going to bring such a lot to aerospace.
This is about how do we start to champion electrification in aerospace? So how do we be able to show people what is possible? When we go to undertake the speed record, there are some rules that are set about how you do that. And those rules require you to do a certain course for a certain amount of time. So planes have gone 300 miles an hour before, but this is the first time we're doing it in an electric plane, and that offers some real challenges.
We're really proud to be rolling out the aircraft now as a clear demonstration of our commitment to cleaner, more sustainable aviation.
It's stunning, and it's going to be wickedly fast.
Wickedly fast. That's the vision. But I think, like, as you saw in the video as well, the challenge is to now demonstrating from a single-seater. The next plan is an 8-seater aircraft, which is something that you can see on the top right, a bit like an air taxi, and then scaling it up to a full commercial aircraft. So this Excel program is a live program, and this shows our commitment to cleaner, sustainable, and a lower carbon power. A bit on electrification. So this is Rolls-Royce globally, but within Singapore itself, within my R&D team, we also have a team that is specifically called RRE, Rolls-Royce Electrical. That team itself is dedicated towards battery technologies and microgrids. These are focused on developing, maturing, and industrializing battery technologies to give us the power that we want. We work very closely with NTU, NUS, and a few other research institutes across the island. And we also have a small little island just off Singapore, where we have a test bed and where we demonstrate on microgrids as well. So it's not just that Rolls-Royce globally is doing a lot on electrification, but even locally, we have a very strong presence and a team dedicated towards making the conversion from these small aircrafts to actual large aircrafts that can, in 10 to 15 years' time, hopefully power our flying. So maybe when we talk about 20 years from now, you're taking a flight, you could be sitting on a Rolls-Royce electric aircraft. And the beauty of that kind of aircraft would be, you would see in terms of noise. So we talked about, fuel, propulsion, and carbon emissions. But there is also a big factor, which is noise pollution. So as you know, there are lots of strict guidelines in terms of where airports can be. And those who are staying in Singapore, especially who stay in the region like Punggol or Tengah, with the jet engines taking off from the military aircrafts, you can feel the power, you can hear the noise. Electric engines are going to be a lot quieter because you don't have pistons going up and down. You don't have the explosion of combustion. And that's going to change the way we look at our future airports, because you could have a tiny airport right next to a HDB block. And this could facilitate Uber for aircrafts. So I think these are some of the key things that we as a company are looking at and have the vision to do it. So I mentioned three things about the fourth industrial revolution. Aviation fuels, so that was on jet engines, but cleaner jet engines. Electrification, so electric engines moving away from jet engines. And the last bit, digitization. So you must be wondering, what has got digitization got to do with, future of propulsion? That's because today, in this digital age, I am very sure you all have smartphones, and you have looked at a lot of fancy new technologies that are coming in our day-to-day life. For example, 10 years ago, we wouldn't have expected to do such a big event completely online. On top of that, there has also been enormous progress in things like artificial intelligence, AR, VR. So I hope a lot of you have gone to those VR gaming sessions in Singapore, where you play different games while wearing a VR goggles. And I have been there, and trust me, it looks very, very real. Now, taking that experience, so the reason I mentioned that is because I want you to visualize how it feels when you're at a VR session. Taking that, we are now applying that to our engines. What we are doing is we are creating something called a digital twin. So literally, we have an engine that goes to the customer, let's say engine number 10101. We have all the parts of that engine replicated on a laptop that's called a digital twin. The moment the customer, so let's say Singapore Airlines takes our 10101, starts the aircraft, taxis, and takes off, our digital twin also recognizes that based on the sensors embedded in the aircraft, in the engine, that engine is now operating. We get real-time feedback for anything that's happening on that engine. Why is that linked to sustainability? That is linked to sustainability because now with that real-time information, we are able to predict any form of issues that the engine can happen, which will prevent that engine from having to take off the aircraft, send it to a shop and do repairs. We can do something called preventive maintenance that allows that engine to fly longer. On top of that, we will be monitoring fuel consumptions and all the other metrics at a live station so that we are able to understand whatever improvements we are making, how effective they are on the spot, rather than few months down the road when we get the data back. Subsequently, there is also an element of support. So in this crazy world, I would say now, travel is almost nil. Things are improving, but if I have a customer, let's say ANA in Japan or Air China, and they have a problem on an engine, the way Rolls-Royce works is we have representatives in those countries, obviously, but we can't have it in all the cities. So a lot of times we have to wait for the engineers to fly down, look at the damage, rectify it, give the customer the solution, and then come back. By having a digital twin, the guy at the bottom left of the picture, he can literally see the engine and figure out what went wrong. And it is really like a James Bond movie where you can look at it, expand it, dismantle it virtually, and figure out what's wrong with the engine and advise the customer on the spot. And that makes it a completely next generation service that we provide to our customers. So just like how I would have liked to be standing in front of all of you and discussing this, but we are doing this online, we are moving towards a similar framework with our customers as well, with data and digitization. On top of that, we have something called the Intelligent Engine program. That Intelligent Engine program is about utilizing the data from the engine and having an artificial intelligence automatically recommending actions to the customer without having human interference. This is extremely powerful because this allows the customers to really own the engine, and it removes the dependency the customers have on engineers who might or might not be available at that time. So having these two things, digital twin, that's the first enabler, and the artificial intelligence for our intelligent engine is one of our third key challenges in this new world, to be able to provide the services to our customers without any form of disruption. So we don't want to just have our customers, but we want to build partners in our journey towards these next steps in the flying. So with that, this is I saw this picture and I really liked it, because this kind of encapsulates everything that I talked about. We want to build a greener future, and aviation has a very big part to play in it. And within aviation, Rolls-Royce also has an extremely big part to play in it. And in order to move towards that greener future, we are looking at sustainable aviation fuels and electrification. And on top of that, we want to have a shadow or a digital twin of our engines so that we can work with our customers as partners and provide real-time feedback for them. And that is what I think the future of flying looks like. This allows us to have deep alliances. It allows us to build partnerships, and that will bring us to the next level of future aviation. With that, we hope that we can continue to deliver on our mission statement, which is delivering power for a changing world. And with that, that's the end of my presentation. And I think I would love to take some questions and comments from the audience.
Thanks, Raj, for sharing. Looking forward to that future of zero emission. We are consolidating some of the questions, and while we are doing that, we'll take the first question. What are the main costs and benefits of utilizing sustainable aviation fuels as compared to traditional fuels?
Okay, it's a very good question, because just before I answer the question, the reason I think that's a very good question is because within Rolls-Royce, even though we, like I said, we are a technology company, but there is so much technology out there. We have limited resources. So we always need to pick the key ones that we want to look into. And that's exactly what we do, a cost-benefit analysis before we launch a technology program or an innovation program. So for sustainable aviation fuels and versus traditional fuels, I think the main costs are three. The first and foremost is, like I said, the lack of power. In terms of running a flight, let's say from Singapore to KL, 45-minute flight, the amount of jet fuel we would need versus the amount of SAF we would need, it's about a factor of 5. And in terms of weight, there's not a massive difference. So you can imagine now the aircraft will have to carry 5 times the weight in terms of fuel versus jet fuel. And the heavier the aircraft, the worse the performance. So in terms of efficiency of utilizing the fuels, that is the first main costs. The second one is supply chain. Like I said, in the next 10 to 20 years, if aviation industry moves 100% to SAF, we would need about 500 million tons of fuel. As of today, I think the supply chain can only provide us with a couple of million tons, and I might be stretching that. So you can see there is a very big delta in terms of the potential demand and the supply. So in order for us to move to SAF, we need to make sure we have the supply, because it's just like electric cars. You wouldn't go to buy an electric car if you realize you don't have a single charging station near your house. Same for SAF. And the last one, which is, I think, the most important one, is the fact that in terms of actual price of the fuel, the price point, because SAF requires so much of R&D and so much, the process is not mature, there is a very high cost to produce 1 liter of aviation fuel as compared to traditional fuels, which has an established process. And that's why there is also R&D work, which I mentioned, a partnership with BP, to bring down these production costs for SAF in order to make it a more sustainable business model. Because at the end of the day, we still are a business. So that's on the costs. In terms of benefits, I think the benefits are very, very clear, because the benefits, the most important benefit is the carbon emission. If you recall back to my presentation, I was talking about every Trent engine, we go about 10 to 15% lesser carbon emission. But that 10 to 15%, we can never break the barrier. We can never go 50% improvement in one iteration. And because that's the challenge, right? Remember, it's incremental growth. But with SAF, we can right away at the starting point cut down our fuel emissions and carbon footprint by 80%. And we can only get better from there. And that benefit is the step jump we need in order for us to reach our target of net zero emissions by 2050. Because if not, that gradual increment, we will not be at net zero by 2050, because it's very, very difficult. So I think that is the biggest benefit. And the second benefit is obviously the fact that this makes aviation fuel life sustainable, because this is made from biodegradable mass, whereas traditional fuels are made from non-renewable sources. And as the name suggests, these resources are non-renewable. They are getting lesser and lesser as we speak. So we will have, moving to SAF, we will have a renewable energy source, and that is the other big benefit. So these are the main costs and benefit, and the benefit outweighs the costs, and that's why we have embarked on this journey to develop SAF.
Thanks for the analysis. So SAF is a more efficient source then?
Definitely.
How do you ensure zero emissions when utilizing electric aircrafts if renewable energy is less available in countries such as Singapore, where electricity is produced through non-renewable means?
Very good question. I'll answer this question in two parts. First part, I will talk about the scale. So Rolls-Royce as a company, globally, we want to move towards net zero emission. And in order for us to do that, we have a global footprint. So definitely it is not possible, or it might be possible, it is extremely challenging for us to get net zero across the globe. So there will be some areas where we will be net positive, but there will be some areas where we'll be net negative. And overall, as a balance, we want to attain the net zero emissions. So that, just to explain the context. Now, coming to countries like Singapore, definitely electricity production is through non-renewable means when we talk about electricity that's powering our houses. But when we talk about electric aviation, we are actually talking a lot more on batteries and fuel cells. Now, these fuel cells are one of the other technologies that we are looking into, where we are looking in renewable fuel cells. So which means fuel cells that are generated through renewable means. That doesn't mean we might not need to have some level of non-renewable means in some places, but overall, we want to achieve that net zero emission. And talking specifically about Singapore, I think Singapore is making a lot of strides into going towards generation of electricity through renewable means. So we have engagements with the EDB as well as Spring Singapore. And one of the key changes I have seen as compared to 5 years ago is in our conversations with EDB and Spring, there is a lot of funding and support available, specifically targeted towards startups and SMEs that deal with renewable sources of energy, especially solar energy. Because I think if you think about renewable energies like solar, wind, water, I think Singapore solar energy is in abundance, whereas in some of the colder countries, you don't have it for about close to 6 months. So there's been a lot of work done with these government bodies to look at focusing on renewable means, especially solar energy. And Rolls-Royce definitely is keen to tap into that for Singapore. Whereas in countries like UK, we might be looking more into wind-powered renewable energy. So I think those are some of the ways we ensure that we hit our net zero emissions using electric aircrafts.
So there's a geographic element to it as well. Depending on which country you're in, you may rely on a different source of renewable energy.
Definitely. I mean, UK basically they have a 1 week summer, so solar energy is not really the best way to go there.
Right. Do we have another question? What was your educational journey like, which gave you an opportunity to work at Rolls-Royce? I think they want to find out a little bit about what your journey, your personal journey was like.
All right. I'm happy to hear that question because so when I was given this task, there was a section of a bit of self-introduction, but I thought, people won't be interested in that. They want to talk about flying future. So I skipped that part.
So I want to know how to go into Rolls-Royce.
Well, happy to share that. So just for the benefit of everyone here, I am not Singaporean. I came to Singapore in 2005. And then I came here in secondary 3. I did my JC, and then I went to university. Now, I was very, very lucky to get into the NTU Aerospace Engineering program. And I did my 4 years of aerospace engineering there. But in my team of 26 pure aerospace engineers, there are probably 5, 6. So what I'm trying to say is aerospace engineering is not the only way to get into Rolls-Royce. As long as you have an engineering background, a lot of what we do is basically core engineering, a lot of the innovation. So for example, out of the 3 things I shared, I did not study any of those in my university degree: electrification, sustainable aviation fuels, or digitization. So in terms of that, today, because aviation is changing so much, it has completely opened up to a wide field of learnings. So yeah, I did my university degree there. Interestingly, I was out of a batch of 90. I was one of those only 5 or 6 who didn't do an aerospace internship. Most of my friends did aerospace internship. I did an internship in a different company, nothing to do with aviation or power, but that's because I wanted to get that breadth. And then after that, I joined Rolls-Royce. So yeah, that was my educational journey like. But I think in order for you to have the opportunity to work at Rolls-Royce, if you listen to what I said, there's so much opportunities in terms of data and digitization, in terms of chemical engineering for SAF, in terms of electrical engineering for electrification, that I think the field is wide open. And no more is it that, oh, Rolls-Royce, you must be an aerospace engineer. I think that assumption has completely gone out of it.
Okay, and to that point, you mentioned that you didn't take electrical or sustainable fuels or digitalization. What was the learning curve like then?
So I have been more involved in the electrification and the digitization. I personally have not been very heavily involved in sustainable aviation fuels. So I can't speak for sustainable aviation fuels, but for electrification, I think the learning curve was very, very steep because everything changed. So when I talk about engines, I know how engines operate. I know you squeeze in the air, you compress it, you combust it, and you blow it out, and then the engine moves forward. Electrification was completely different. We were dealing with batteries, permanent magnets versus temporary magnets, wiring, resistors, capacitors. This was a very big step jump. But I think what helped me was, at the end of the day, even in Rolls-Royce, we never focused on just one thing. We understood different aspects of the engineering. And if you ask me, engineering degree is not just about the knowledge you pick up. It's about the thinking. It's about the thought process. So to be honest, I don't think I applied 80% of my notes that I studied in my work. But what I did apply was the problem solving. What I did apply was, when I look at a problem, how do I define the problem? How do I find the root cause? How do I solve it? Those are the things I did in university that made my learning curve a lot less steep when it came to electrification. And the same goes for digitization. I think digitization is very, very exciting. I personally have been very excited by the prospect of working with some of the digitization stuff. And it's, again, the same logic. It's about problem solving rather than focus on the technical aspects. And obviously, you have other engineers around you that have special skills, that have specialized in that field. So you don't need to do all the work, but it's all about taking a problem and finding a solution as a team that allowed me to, ease into this learning curve.
Easy. Okay, so the nature can be very different, but the core skill sets don't change very much.
Always.
Okay. I think we have time for perhaps one more question before we end. So since most of the improvements made are in the mechanical side of the aircraft, is there any way to improve in the electrical side / avionics side of the aircraft?
So the short answer is yes, definitely yes. The more in-depth version of the answer is that I think the reason why the focus has been on the mechanical side is because if you take an aircraft or an engine, and you take the carbon footprint and you split the engine into different parts, I would say 80 to 90% of the carbon footprint is, and I'll use the word fault, is the fault of the mechanical aspects of that aircraft or engine. So that is the reason why I would say most of the focus has always been on improving the mechanical side. Now, I'm not saying that, the electrical avionics side of the aircraft is not different, is not important, but purely if I'm talking about, so I'm not talking about, making the aircraft smarter or making more money out of the aircraft, but I'm purely talking about sustainability. Then making massive steps in the avionics side of the aircraft is going to have not such a significant impact when we talk about sustainability or future of the flying. So that's why the focus has been on the mechanical side.
Thanks for that, Raj. There are a number of Q&A sessions, questions, but due to constraints of time, we won't take them. So for all the other questions, if there's any questions that the audience have, please direct them to social media, and then we'll forward them accordingly. Raj, I would like to thank you very much for being here with us today and sharing your insights. It was very valuable, and I think that the audience enjoyed it very much. So thank you.
Thank you so much for having me. And yes, please, I'll be very happy to answer these questions offline. And because I know I've read some of the questions, they are really, really interesting. So I will have a think about it. I will answer them offline. And Johnson, please guide me on how can I, bring the answers to the participants.
Certainly, we'll take it offline. Thanks, Raj, again.
Okay, thank you, guys.
Thanks. So to the audience, coming right up at 3:45, we have Mr. Scott Slip, Assistant Director from Ngee Ann Polytechnic School of Life Sciences and Chemical Technology. So we will be exploring the careers and skill sets required when you embark your careers 5, 10, 15 years down the line. And if you have not already signed up for this event at Astra that's coming up on the 1st of July, you'll be prompted to do so after the session. There's also a link to sign up in the chat. I'll see you then. So thank you all for being a great audience. Please give us your feedback and I'll see you at the next one.